Good morning, ladies and gentlemen. Welcome to another �12𝙮𝙗 webinar. I hope you can see my screen. Today's webinar will be focused on connection design and specifically on steel structure with composite deck. So you have a lot to look forward to. I'm here today joined by Łukasz Juricek, our senior product engineer. Hello, Łukasz.
Hello, Dominic. Hello, everyone. Good morning. I'm sorry I can just expose my face because my camera is not working at all. So the first technical trouble. I apologize for that.
That's fine. I hope you didn't get sunburned, and this is just an excuse not to show your lovely face. Jokes aside, my name is Dominik 𝙁𝙀𝙮. Hello, I'm also a product engineer, and this webinar will be brought to you by the two of us. If you are new to GoTo, just be aware that you are all muted by default. However, you can ask questions in the GoToWebinar panel, and there will be 3 polls during this webinar. And we encourage you to ask the questions. We will be answering them during the webinar, and if there are some that we don't answer during the webinar, we will answer via email afterwards. All right, so the introduction. Steel connection design can be very complex, time-consuming, and tedious, especially when you have changes and requirements, and everything has to be done manually. However, today we will take a step back and explore 3 topics: what a connection design looks like without using 𝙤𝙗𝙮𝙗, that means with some standard tools, and how 𝙤𝙗𝙮𝙮𝙗 can transform this workflow with the application 𝙤𝙗𝙮𝙮𝙮 develops. And then finally, we will explore during the workflow some workflow tips, touch some hot topics as eccentricities, model types, and even nonlinear combinations. So you have a lot to look forward to. And now, I would like to show you, I would like to launch a poll with the question: what tool do you primarily use for designing the steel connections right now? So is it Excel spreadsheets? Is it some various add-ons or built-in modules in your global analysis software? Is it 𝙤𝙗𝙮𝙮𝙮? Or is it something completely different? And if that's so, please take a vote and share it in the chat. And with that, I am launching the poll. And you guys are already voting. So what is it? I will give it a few more seconds. 60% of you have already voted. It looks quite well, and I'm a little bit surprised, to be honest. Okay, few more seconds. I'm closing the vote, and hopefully you can see the screen, because 19% of you use Excel spreadsheets for connection design. I'm not surprised by that. Only 7% of you use various add-ons and built-in modules. That comes to me as a surprise. A pleasant surprise is that 68% of you use 𝙤𝙗𝙮𝙮𝙮. So that's great news. Thanks for that. And 6% of you use something other. So we'll be looking forward to seeing those answers in the chat. With that said, let's move on to the structural model, and I'm handing the word to Łukasz.
I do believe that you're not waiting long time. So let's get started about the structural. I'll just share my screen. Okay. So I do believe that you can see my screen, and we can start over the description of the structure. That's great. Thank you. So what we prepared for you, that's a 4-story residential building that will be there is just the composite deck that is providing the distribution of the forces over the beams. So from the geometry perspective, we can say that the width is like a 16 meters time length, 36 meters, and the height is like a 16 meters tall building. We have like 4 stories that's are braced in one and the second directions. Some attributes about the structure: there is in total 551 nodes, 724 members. We were working with 6 loads. That some of them are like a permanent load cases, and the others are like variable as a snow and the wind and the cars, of course. And we have automatically generated 4 combinations, because this is like a standard procedure what structural engineers are doing. Okay, what about the connections that will be designed today, or are already designed? We'll be touching a little bit the anchoring and some assumption what you need to follow if you are designing the anchoring connections. Some designed moment and the shear connections that will be explained, some pros and cons, and also the design bracing connections, typical bracing connections that are providing this lateral stability of the structure. So that's been just briefly intro about the structure, and I will pass the word to Dominic to mention something about the analytical solution that is on the table. Dominic, if you can hear me, it's up to you, man.
Yes, I can hear you. Can you hear me?
Yeah, everything is fine. Thank you. Yeah.
All right. Okay. Thank you, Łukasz. So the analytical solution. Let's take a swing and let's see what are the steps. So obviously, when you use this type of workflow,
Dominic?
you start your global analysis software.
Dominic,
yes?
I cannot see your screen.
You cannot see my screen.
I'm not able to see your screen. It's blank.
I'll trying it.
Yeah, right now that's great.
Maybe give me a little. Okay. It seems that we both have some internet connections. This webinar is done from the field because we're both at home. Our office is being reworked, so that's why we have some technical issues. We apologize for that. Coming back to the topic of analytical solution. So the first step is that you need to gather your internal forces from the global analysis software. You collect all of the load cases and combinations, probably export them to Excel spreadsheet, and then you start identifying critical load effects to identify maximum positive, maximum negative for axial force, shear, and moments. And then you start grouping these connections, and you define types, groups like beam to column, column to column, base plate connection types, etc. Then you input this data into either the Excel spreadsheet, which you have already defined previously, or the simple connection tool. And you define the geometry and start code checking, and probably iterate to receive positive results, and with some little optimization. And obviously the last thing is that you need to hand over your work. So that means generate a report, prepare some sketches for the fabricator, and the report consultant, etc. Okay, and now one change in the model, and you have to start all over again. one single change can have a huge impact, and it's very hard to keep a track of that. So connection design can be painful. It can be very time consuming. There's a risk of mistakes when there's so many manual transfer of data. It's tedious to do modifications. It's really no automation is provided at this workflow, and it's very poor to poorly trace any changes in the model. However, luckily, there is a workflow with IDEA StatiCa, which we'll be covering today. But before we jump into it, I would like to launch a second poll, and with the question, what part of steel connection design is the biggest bottleneck for you? Is it the pre-processing, the load extraction, grouping connections? Is it modeling, especially in the case of IDEA StatiCa? Is it handling the complex connections? Or is it communication and coordination with detailers, fabricators, or consultants? Or is it something completely different? If that's so, again, please share it in the chat. And I'm launching the poll, so please take a vote. Again, I will wait a couple of seconds. Curious results so far. Seems like that for most of you, communication and coordination with the detailer isn't the biggest bottleneck. Again, 3 more seconds, and I will close the vote. All right, so 27% of you have voted pre-processing, load extraction, and grouping connections. So hopefully you will find this workflow, what we will show today, helpful, because it covers that. Then 18% of you answered modeling. Interesting. And 45% of you answered handling complex connections. This doesn't surprise me. It's always a bottleneck for everybody. 9% of you communication and coordination with the detailer, and 2% something different. All right. So now we're moving to the connection with IDEA StatiCa. An essential tool in this workflow is Checkbot. So for those of you who don't know what Checkbot is, it's an integration tool that allows you to connect your FEA global analysis software and CAD software with IDEA StatiCa. What you get, you can import geometry and internal forces, especially for the FEA. It detects the critical load cases automatically, groups connections based on geometry, and that is done for the efficient design, and keeps everything synchronized, mainly the loads, when the model changes. And in terms of CAD, you can also import individual components such as anchors, bolts, and welds. And from Checkbot, you can open individual connection and perform the design, and also when you're done, export with the IFC or your application. Okay, that's the introduction of Checkbot. I'm handing the word back to Łukasz.
Great. Thank you, Dominic. I will just take it over and move it. Okay, I do believe that right now you can see my screen in the full screen. Is it correct? Can you just confirm, Dominic, if you can see it?
I don't see it yet, but I see it now. So
amazing. So we can move forward. So right now is a proper time to introduce how to export the structure or the part of the structure from your FEA to IDEA StatiCa Checkbot. That is basically like a HubSpot for all the connections that will be designed and saving all the informations about your detailed and designed connections. So in between, I just open up the. We are working with robot structure analysis. That's but I would like to talk in general about the FEA, because the structure can be, of course, designed in every FEA structure. So or FEA, sorry, global tool. If you have a structure like this, at first, what you need to do, you need to at first calculate the internal forces. So run the linear analysis to get the internal forces. So if you have it, you will just double check if everything, like a sanity check, if everything is fine. So you need to have installed this plugin. This plugin exists in add-ins for this tool in the IDEA StatiCa. So if I will just do that, I can just export the whole structure. But this is not my goal, because I would like to work with just part of the structure. So I will just select the first floor, and the connections again, like this. Okay. So right now, as you can see, I can just select all the members what I want, and I can just export it to IDEA StatiCa Checkbot. Right now, yeah, the Checkbot is starting, so you need to read out like all the informations, you know, and pass the information to Checkbot. So in between, the application is starting. So to avoid waiting, I just you know, open up and export to the structure. So it looks like that. What you can observe that the connections are basically grouped. They are grouped based on the topology, based on the connection, based on the uniqueness of the sections that you have. Yeah, right now you can see starting, but we can just move it or skip it. Okay, so this is the goal, to group it and just to play around and design the master connections, and all the connections that are basically slave connections will be designed accordingly. I think Dominic will be discuss it. We talk about it later. So that's been the goal, to show you and introduce how to export it. And let's get to the definition of the anchoring. I was mentioning that I need to tell you the strategy or some idea that we stepped into the simulation of the structure, because this webinar should be more focused on the engineering approaches and engineering judgments that you are using during your design and ideas. So the connection, as you can see in the global model, I just considered the pin connection. So to verify my solution, I need to somehow advocate that the hinge will exist, and I can consider a hinge connection. So how I can do that? So I guess I can provide you some option that you can run the stiffness analysis. So I just take it out this connection and put some bending moments and run the stiffness analysis. What is very important, you need to assign properly this length, and you need to set in the application that your system is braced. So based on that, the boundary will be changed for rigid connections. The pinned connection is not affected. But as you can see, based on the simulation, the initial stiffness in the Y and the Z direction, they are quite low. So we can say that it's been classified as a partially restrained connection. But I think the engineers are just following the rule that they are designing hinge or just the rigid connections. And if I can say, or what I can say, that the partial restrained connections has been classified, but they are very close to the pin connection. So I can say that my assumption for pin connection is fulfilled. And mostly all the like a tensile or the forces from the transverse directions are going over this bracings. So I'm just quite safe at this point. And we can just move on to the eccentrical connections, because on every structures there exists some eccentricities. They allow you basically the practical detailing, accommodate geometry offsets, enable bracing layouts, and provide space for like a cladding or services, for example. even though they introduce moments and they are often unavoidable to meet architectural and functional requirements. So I do believe that everybody from you who is listening met the eccentricity on the structure and needed to handle somehow. So those are some eccentricities, or some of them that are quite obvious on the structures like this. So multiple members and different center intersections, top flange alignment, and bracing optimal direction. So that's are like typical use cases and typical connections. But what structure engineers need to pay for that if he consider eccentricities, or when eccentricities exist on the structure? It leads basically to induces like a secondary forces, mostly like a bending and the torsional moments that you need to consider during your design. It can also lead like an unequal distribution on the forces, and also increasing stresses or additional stresses in the welds that you should or could handle in your design of the connection. So eccentricity does matter. And what about the FEA model and the eccentricity? So that's a quite huge topic. And many engineers like overlooking the eccentricities, and what can be the consequences if you just neglect it. So the truth path of the laws is basically ignored, or without the eccentricities. So from my perspective, what I think, so the critical at least the critical members should be considered with the eccentricities, and the secondary members can be like a simplified. I'm just talking about the global FEA. Of course, there are some setbacks that can happening during like a tuning up of your global FEA, that if you would like to modify or scale up your structure, that can be quite challenging. So those are some setbacks that can happen during if you use the eccentricity. But how to consider, or is it necessary to consider the eccentricities if you would like to use IDEA StatiCa member? Yes, it is. Yeah, because if you import it with the eccentricities, there is like a true load path on the structure, and in the IDEA StatiCa checkbot, we are just enabling you to merge the nodes basically into the one single node, but with also consideration of the eccentricities and mostly the internal forces that's like exist, like additional internal forces that exist due to the eccentricities. So our recommendation is to use the model of the eccentricities to export it to IDEA StatiCa checkbot and do the design inside IDEA StatiCa connection. So I think that's this is my part. My part is finished, so I can just pass the word to Dominic. Dominic, are you there? I'm not.
Hopefully.
Yeah, I can hear you, man. Yeah.
From my screen. Okay. And I believe you can see my screen.
Not yet. Not yet.
Okay, let's give it a few seconds. Today is a slow day. It's a lazy Wednesday, seems like, for the GoToWebinar platform.
Yeah,
Let me know when you can see it.
Yeah, maybe start it over. Just try it again. It's not displaying at all.
Okay.
Yeah, right now I can see
now?
I can see your checkbot model.
All right. Okay. Thank you very much. So we're back in Checkbot. So for those of you who don't know Checkbot at all, obviously you can see the 3D scene. Similarly, as in connection, at the top you have a ribbon where you do the design. Then move on to the report. You can access materials and even to send information to Hilti Profis. On the right side, you have a tree of the connections, and they are grouped. You can see that they are this arrangement 1-1 is if I click on the group, it's all of the columns that are ended. So that would be a base plate connection. What I will do is that I will design only one of these connections. That's the underlined one. We call them a reference connection. And the design from this connection will be propagated to all of the other ones, and then you can just run the calculation. However, we have quite a few combinations here, quite a few connections. You can imagine it's going to take a lot of time. So how do we save that time? If I go to group, at the right side, I can find calculate load extremes. So I click on that, and our algorithm gets going, and it identifies critical connections with critical load effects, and it provides, it groups them. So when you run the calculation, let me get back to the presentation to explain, you can save time. So for every connected member, select the most extreme load effects based on the following criteria. For load component extremes, maximum and minimum or negative and positive axial force, shear forces, moments, shear force and bending moment resultants, normal resultant and maximum stress at the edge of the cross-section, shear resultant, and total resultant of the force acting on the member. So if I put them all together, theoretically you can get up to 20 of those, and you can find everything in this load extreme selection. You can find this article which describes what I just said. You can study it. It's basically quite simple, but it's automation, and that's what we need in our design to save time. And what is the effect? When I open the connection in single connection application, you can see that many of those combinations or load effects are disabled. That's because they are not found critical, and only the critical ones remain active. Then back in Checkbot, when I click on the details, this little window pops up. The UI is really not up to date. We're working on that, so within the next version, you will see an improvement over there. But you can find basically logs of that algorithm, what it does, and you can find the extremes, the extremes in this. I can't find it right now, but it will be this. What's nice that you can just select it and bring it to Excel spreadsheet if you would like to get to understand it, and that's obviously very, very important. So let me get back to connect Checkbot, because I would like to, what I'm going to design is 3 of these groups. So I need to calculate the load extremes for this one and for group 4 as well. So I'll calculate the load extremes there. All the other groups, so for example, group 14, which I haven't touched, remains still active for all of the load effects. So no change has been done. So that's something about combinations. And there are a few more things about combinations that I'm always curious about. I want to find out more. So Lukáš, can you tell us about the envelope and nonlinear combinations idea StatiCa? Can idea StatiCa handle that?
Yes, Dominic. So I will give you precise answer. Just right now, I will sharing my screen. So
I see it.
Let me know if everything is fine.
Everything is fine.
Right now you can see the envelope combination. So what we support, because as we know, you are working with the envelopes a lot. Like every structural engineers are working with the envelopes a lot, and like taking out the linear combinations out of it. But can idea StatiCa Checkbot handle the envelope combinations? Yes, idea StatiCa Checkbot can handle the combinations, but what is very important, the combinations need to be like a static loads, composed from the static loads. nothing like a dynamic or moving load or settlement. So those are the envelopes that we do not support. We support the static load combinations. I mean that there are just the permanent and of course some variable loads, but they are defined as a static loads. So that's very important to mention. And for those who are using like a nonlinear analysis in their softwares, like a geometric nonlinear analysis to get some like second order moments and additional internal forces due to the increment of the deflections or deformations. So I have like great news for you that we support the nonlinear combinations, but there is very essential to understand how we are translating or transforming the combinations into the 𝙭𝙮𝙮 checkbot. So as you probably know, the 𝙭𝙮𝙮 checkbot works with the internal forces. We are not working with the loads. We are just taking the internal forces from the nodes and also and the members and going to 𝙭𝙮𝙮 checkbot. So we are importing the internal forces near the loads. So this is the reason why we need to just upload the nonlinear combinations as the nonlinear load cases, because you know there are some consequences if you are using linear and the nonlinear simulations. So if you are using like a linear analysis, you can just superimpose the internal forces in the post-processing. That's valid approach, that's legit. But if you are using the nonlinear simulation, so this assumption is not valid at all. So this is the reason why we are just exporting as the load cases, as the single load cases that you just added to the result classes and to work with that. Also, the combining of the results, as I mentioned, is support for linear analysis, but not for nonlinear analysis. It's not supported, so you are not able to scale up the I would say load cases by some factor and combine it together for nonlinear simulations. So this is the reason why we just using the nonlinear load cases that are extracted from the combinations in your FEA, but we support that. That's important. Okay, Dominic, I think it's your part, connection design, anchoring design.
Yes, it
Go
is.
ahead.
Once again, the crucial part. Let me know. You can see my screen.
I can see Checkbot.
That's good. That's good. If it's my Checkbot, then it's that it works perfectly. Okay, let's proceed. Let's proceed with the design. So group number one, you can see that I have 27 connections here, and I want to design just one and the design to be propagated to all the other ones. So when I click on the reference connection, which is underlined, I click on open, and single connection app, that's how we call it. You can tell the difference between standalone connection and a single connection app, single check app by this gray top bar. And I will proceed with my design. You can see that all of the load effects actually are disabled because none of them is crucial. So I will activate just one because I will want to run the analysis to see if everything is fine. And I'll start with the traditional operations and define the operation of base plate. I'll do few modifications. For example, I increase the thickness to 25 and I want the dimensions to be set as a rectangle symmetrical. And with that, I want to create the connection that was showed by Łukasz previously, the anchors. That's something new in the new version installation process, cast in place. We differentiate by that. And I want to define the washer plate anchors. However, I want to change the type to 10.9 and M22s. Perfect. Washer plate size equals to 50 millimeters, and embedded embedment depth is 220, and the left layer sits at 100. And as you remember, there was only one layer, so I believe this is it. The welds we will increase those to 10 millimeters. and I want to use the S235 for both of them. It's great. And one last thing, standoff, I want it to be a mortar joint with the thickness of 30 millimeters. Okay, I believe my design is ready. To verify, that's why I have enabled one of those floats. I will just calculate it real quick, see if the analysis runs. It runs, so I think it's fine. What I want to do is I want to save this design for future purposes. So I want to publish this design, and I will publish it to my connection library. So publish it, I'm publishing it to my personal set. However, I can also publish it into a company set. What that means is that your colleagues working on the same license can access this design. So I'll publish it. And with that, I come back to Checkbot. Oh, I didn't save it. I need to save the design. I come back to Checkbot, and I can see that this connection is calculated, and all of the other ones have the design propagated over there. So if I open N12, I see that the design is there. Nice. Okay, I will not calculate it right now, but what I would do normally is that I click on the group number 1 and calculate all, and the calculation runs. However, I want to proceed with the design of group number 3. And I open this connection. And there it is. All of the load effects are activated, so I don't think I have actually calculated all the extremes. That's important. So I need to enable that, because that's what I was showing you previously. Okay, I'm getting a little bit of lag. That's fine. And now I will open the reference connection once again. Another thing that is new in version 25.1 is that you can also click on running the buckling analysis as well automatically from Checkbot. So for all of the groups, the buckling analysis can be set from Checkbot. Okay, let me drag the single check app on the main screen. You can see that some of them are already enabled because they are critical, and I want to do the design. What I will do is I will use the design that I have done previously. I don't want this one. I want the same base plate. You can see that it's not finding it because I need to select selection and just click on the member I'm interested in, and then confirm my choice with this button. And now I see, is that the one? Filter out only personal, and for webinar, apply. Can close connection library. I'm almost finished, and now I just need to connect the bracing B792. I will do that with traditional operation of connecting plate. So I'll click on that, connecting plate, so I can combine the traditional the operations with templates. I need to modify it to connect the member, the bracing itself, and then I will just modify the stiffness, width, depth on that plate, and position equals to -150, X position equals to 300, X position. And I'll change the cap plate to cap plate twice. You can see I have 2 plates here, cap plate twice, and 120 times 120. Very good. I'll check in the transparent view, and I can see that the connecting plate is have a collision here. So I'll click on the connecting plate, on the right click on editor, and create a chamfer with the selected corner 3, value 50. Apply, and the design is done just like that. And I also need to modify the welds, forgot about that, and change the grade of the welds to S235. Very well. Every finite element model has its own supports. What I need to do over here is modify the member. You can see that most of these parameters cannot be modified because the checkbot is superior to that one, so it would have effect on the global model. However, I can modify the model here and change the model type. Model type NV, VY, VZ, EMS allows for the movement in all direction. However, I want to change it to NVY, VZ. You can see that this little cross has appeared here, meaning that it's only allowing the transition of axial force and the shear forces. Once again, I will calculate it to verify if my design is correct. Because if it wasn't, and I would leave all of the 6 degrees of freedom there active, I would most likely get a singularity because I only have one bolt here, and therefore, and the bending moment would create a mechanism. So it needs to be in correspondence with the global model. One very good check is that when you click on the check tab, and on the right you find the analysis, you're getting some non-conformities. This number you in general want to keep it as low as possible. All right, I know that my design is correct, so I'll save it, jump back to Checkbot, and now I can just run the analysis, and Checkbot is calculating that. You can see that the first one is being calculated again, and the rest of the connections in the group are being in line. Another new feature in the newest version is that you're getting a progress in the top and the bottom right corner, and you can also cancel. Okay, I would like to show you a little bit more about that model type, when it can be used, especially when you have a channel section like that and you just apply a shear force. You might be getting some deformations that you wouldn't expect. You're getting some torsion because the shear force is being applied to the center of gravity. You know where I'm going with this. So you need to restrict it. You need to add some additional boundary conditions. Everything is described in this article. It's called model type, additional boundary conditions. Over here at the bottom is specifically the same example with the channel section. You can read about it, see when how it behaves. You can also download the model and test it out for yourself. All right, I'm handing the word back to Lukáš, who will show us the last connection design.
Amazing, Dominic. Thank you. That's been very important to mention how the boundary condition works. And I think every structure engineer should be familiar about the like essentials where the boundary conditions are basically located, or where is the boundary conditions, how it's affecting the members if you assign some model types, because it brings up the clearness, and some your sanity check, will be is very important. And if you do not understand how it's built up behind, so it's very crucial that you can for example do like an error or a big mistake. So this is the reason why we just came back to the roots and explained how it works, because that's from our perspective is very important. I do believe that you can see my screen.
Yes.
And you can see my connection. That is basically the shear connection, where is on the top of that is the composited slab. So I will be talking mostly about these connections and the constraint that you can see on the top, and also about how the composited deck need to be like set up in the reality to fulfill the assumption and use it inside the idea StatiCa. As you probably know, and you are like a familiar user of idea StatiCa, we are not able to export the composite deck. We are just importing all the steel structures. So you need to do some steps also in the reality on the construction side to fulfill the assumption also inside the idea StatiCa. So at first, about the constraint that will be used, that is substituting the composited slab. So we just developed this lateral torsional restraint, not only for the composited like a deck or slabs. This is also for sandwich panels and many more usability. But at first, let me talk how it works, what features, what constraints are used on the top of the flange. So as you can see, this is the detailed model that we are supporting that is bypassing the sealing or the claddings. There are some lateral stiffness springs that can be assigned inside the idea StatiCa and like restraining you the lateral movement, and also the rotational stiffnesses that are basically linked with this constraint equations to every node, and like a transforming using the weights the stiffness to the other points on the top of the flange. So that's important to understand that we are just supporting the continuous and the discrete redistribution of those constraints. And what about the composited slab? So as I was mentioning, we are not allowing to import the composited deck. So if you would like to consider the design just the steel part without this composited deck, you need to follow that the basically reinforcement in this direction need to be disconnected, because if you are close to the, I would say, in the negative moment area, so there will happen some crack on the deck, and you can just exclude this part from the simulation. But there is some continuity because there are some rebars that have some bond. So you if you just keep the reinforcement in this direction, so there will be created like I would say coupled normal forces. That one is tension in the deck, and second one is going as a compression normal force into the beam. These effects are basically neglected if you leave up the continuities of the reinforcement rebars. This effect will be dismissed. So you need to be very careful during the design of the composite deck, and if you would like to do it using the Checkbot. Of course, if you just take the idea StatiCa connection as a default tool and started from the scratch, you can a little bit bend up the model and work and play around with that. But for idea StatiCa Checkbot, that's basically the import, of the composited slab is not supported. So this is the reason why I was mentioning that the model that we are using, there is just the composited slab with those assumptions that provides you just the distribution of the forces, but basically in this direction where is the negative bending moment, and there is discontinuity of the reinforcement rebars that are already there, and we are enabling the crack, and you can just utilize the concrete or sorry, the steel, the idea StatiCa steel connection for the full capacity. So this is the assumption that we have, and I think I will just move to modeling approaches. As you can see on the structure that's been sorted according to the group to many connections, and the connections will be designed in the same way. So basically, if you open up the reference connection, so the reference connection will be looking like that, and you have all the internal forces, and also I use the evaluate critical. So as you can see, those are the critical combinations that are used. And let's get and use the connection library and the propose button. So if I will do that, as you can see, there are some predefined sets that Dominic was already mentioning, but I will use this double cleat, yeah, to make it like a symmetrical. I don't want to add any other like additional forces due to some eccentricities. So as you can see, the template that's been already created just to inform you that the model type should be used N, VZ, and Y. That's valid if you have like a one-sided cleat, but if you have double like a symmetrical cleat, this notification can be disregarded. So that's not valid for this connection. What I would like to add, because we are using like a parametric templates that has some parameters here, I can just add on the top the operations that will be really on the top of the flange. So that's lateral torsional restraint. This is here, and you as a user, what you can do. As I was mentioning, you are able to assign if your type will be continuous or discrete. In my way, because I know that the headed stats are after 150 millimeters, so I can just use the discrete redistribution after 150 millimeters. What about the torsional restraint and lateral restraint? I know that when the stats happening here, so I can say that the plate or the slab is basically rigid in the lateral direction, so that can stay like a rigid. But what about the torsional restraint? As we know, that's a concrete deck that's fully composited. So you can say also that your torsional restraint can be rigid. If you basically don't believe, or if you want to try it out how it works, if there will be like a different stiffness, of course you can just assign your torsional stiffness, but this value is quite like a magic number, I would say. So some sensitivity study is quite like a good choice. This is the reason why I just leave it as a rigid, because this is the concrete floor. We have some verification or some article for sandwich panels. That's you can find it here. If I just open it up, you will see that here is the article that is like postulating something about the lateral torsional restraint in structure design, how it's the stiffness can be recalculated to make it discrete or uniform, but mostly the sensitivity analysis and comparison with Abacus, that it works properly and well. And here are some equations that are working for sandwich panels. Yeah, so here is something for sandwich panels, and also the article that is basically here. Yeah, European recommendation on stabilization of the steel structure by sandwich panel. This is for sandwich panel. This is not for steel, for a concrete composited deck. But as we know from the research, basically that the stabilization forces, or the destabilization forces are really low against to the stiffness of the concrete deck. So we can just consider that this torsional stiffness will be set up as a rigid. So I will just copy my operation in the same way for beam 157 top flange 1. Ouch, what I did, maybe something wrong. I will just do it again. Yeah, this is correct. I need to just assign it to another beam, top flange. And right now I have this restraining. Yeah. So what you don't need to like omit is to the internal forces. If you double check, and you will check the beam. So, and the trend of the internal forces, I mean the bending moment, there need to be assigned that the shear force is coming through the bolts. This is not like a general rule, but for this type of the connection that is really shear connection, the shear force will be going or passing through the bolts. How to do that? That if you just go to the beam and you will just assign that the forces are coming through the bolts, you will get this proper shape of the bending moment. That's very essential. What will happen if you neglect it? So I will just introduce you. I will just show you what will happen. So that's again the essentials. We are repeating the essentials, but we know that it's very important. So the position of the forces that is very necessary to assign properly can be in the node, bolts, and you can just use the position if you don't want to use it to passing through the bolts. But what will happen if you neglect this information, and you will run the simulation without this shifting of the shear forces. What is basically happening? As you know, here is just the beam, and your theoretical hinge in your global FEA is here. So I mean that the bending moment looks like that. So at this position, there is like a positive bending moment that is causing the rotation. But if you do it properly, sorry for my drawing, so you just shift the shear forces here. So it means the bending moment looks like that, and there is just the shear deformation. This is the proper evaluation of the shear connections. Great. We can just move forward. That it's not true, as I mentioned, this is not like a general rule that you need to follow. You need to think about it. You need to think about it because every connection is unique. And this is like a great article from our colleague Pavel Kalab that is basically that was exposing how the shear forces need to be applied for the different type of the shear connections. So if you just step into the article, so that's very valuable article from the sense of the informations and the 𝙏 on basically the how it works, how it should be assigned the shear forces properly for different type of the connections. As you can see, it's not always true that the shear forces is going through the center of the bolts. It will be shifted. The reasons are very well described and verified with our idea StatiCa member. So do not hesitate and jump in on this article to see that there is a lot of information, valuable information. Equilibrium, another very important topic. I would like to touch a little bit the unbalanced forces and what it can cause during your design, during your designing of the connections if you neglect it. So we have just this connection that is coming from the truss structure. As you can see, this is the bottom chord where are just the tensile forces. And this is just the working joint that you need to just connect it some like more members together. So the bottom chord that is basically under tension. As you can see, the loads in equilibrium is activated. All the forces making the sense if you just do the decomposition. So you will get the equilibrium in the horizontal and the vertical direction. Perfect. I did everything perfectly done, and we can just run the simulation. So as you can see, those are the forces in the bolts, 73 kilonewton. But what will happen if you disregarded this rule? And as you know, here will be 240 kilonewton because the support is here. So this is the unbalanced forces. The forces need to miss somewhere, you know. And what it cost? As you can see, the forces here is 98 kilonewton. Should be 200, and this is the reason why the forces has been basically decreased and are wrong, and you will get like a lowered value of the forces in the bolts. So please keep in mind that the equilibrium is the essential principle of the physics and should be always followed on your design. So this is wrong, this is correct. As you can see, the forces are basically doubled for precise solution. Amazing. So we can just moving to the chapter 9. That is like a cherry on the top, because we know that the first design is not like a final design. So you need to iterate, you need to do some changes because of the construction side, because of some errors on the structure. I mean, on the construction side, that can happen. That's like a daily routine. So how to do it with our tool, with StatiCa Checkbot? We have like a magic button that is called synchronization. So we also did like a mistake during our design, because as you can see, I was just designing this part or this floor with the anchoring, but you will see what I missed. So at this structure, if you just hit the connection like that, as you know, I'm just connecting or jointing like 4 members together. but one from the member is missing, and this is the column. So if you just open up the connection and you will just press some load effects, you can see there is some unbalanced forces. And why? Because I forgot to add the members. That's gonna happen. Yeah. So what I will be doing, I will just come back to idea StatiCa or RCS or Rouble Structure Analysis, do apology, and run the synchronization. If I do the synchronization, so all the operations that are already on the connections will be remaining. This is just the project without the connections that's already designed. But what is very important to mention that we just edit the members. If I will step into the connections, hit the load case, as you can see, it's balanced. That's perfect. This is how it should be working, this synchronization. It's also valid for like a cross-section changes, loads changes, combinations. So last chapter of this session is the report, because we have added, since version 25 has been released, 25.1. So there is just the report in the Checkbot. There you are able to print it out, the reports, and in the bulk, I mean, and you have like all connections will be in the one report, and you can just list it, all the connections, and send it out to the contractor or whatever you want. So this is the goal why we just added the report, to have some like everything merged on the one place. So I do believe that I didn't overwhelm you with so many informations, but for us that's been very essential to share what we said. And here is the summary that is like going to Dominic. Dominic, are you there?
Yes, I am, Łukasz. I'll just wait to share my screen. Please confirm that you can see it.
I can see that. I can see your summary. Yeah.
Wonderful. Thank you. Thank you for covering so many topics so extensively. The bulk feature for report is new. It's lovely. I will save you a lot of time. Let's proceed with a summary of what we have covered in today's session. So Łukasz talked about how to handle eccentricities when coming from the global model, and how to work with that in idea StatiCa. Then we looked at how the combinations work in Checkbot, and again how to use the evaluate critical load effects functionality, and we got some information about the envelope and nonlinear combinations. We designed connections with using Checkbot. We incorporated the connection library approach with using individual manufacturing operations. Another thing what you can do is utilize the parametric templates functionality, which again helps the automation as well. Then we touched upon the topic of principles of designing in idea StatiCa, the model type, the position of shear force, and again the eccentricities and loads in equilibrium. It's always important to have that on and keep the forces in equilibrium. Then Łukasz showed us how to use this sync functionality to synchronize the Checkbot with global analysis FEA model. And then finally, outputs from idea StatiCa. We only covered the report, but you can also use the sketches in the report and then export IFC from Checkbot directly to send it out to detailer. That was it, and I hope you liked today's session, and I would like to launch the last poll of today's webinar. Let me see. I'm launching it right now, and I'm asking you, how likely are you to use idea StatiCa for designing steel hole connections and other projects in the future based on today's session? The options are that you already use idea StatiCa, or you're very likely to use it. You see the benefits clearly. So somewhat likely you need to explore more. If that's so, please explore those articles that we have shared, and maybe not likely you prefer your current workflow with the Excel spreadsheet or some other things. Very well, I can see that most of you have already voted. So I'm closing the vote right now, and the results are 65% of you already use Idea Statica. We're very pleased to hear that. 20% of you said that you are very likely to use it in your projects. You see the benefits. Again, we like it very much. 15% of you, somewhat likely you need to explore more. And nobody said not likely you prefer your current workflow. Well, this is amazing feedback for us. Thank you very much. And one last thing, if you want to switch to Idea Statica, you see the benefits. Scan this QR code. It will take you to a landing page dedicated to this workflow, and you can get your individual quote, talk to your resellers in your region, and get on the board, start using Idea Statica, and save time. Thank you very much for tuning in today. We're already past our usual hour, but we still want to give you some room for Q&A. And I have a question here, which is asking me about the parametric templates. Parametric templates. How does somebody find out more? Lukáš, could you answer that question? How does somebody that would like to start using parametric templates get on board? You were heavily involved in creating documentation for this functionality.
Yeah, you're right. You're right. So just give me a sec. I will just share my screen and show you where you can find it on the page. Yeah, just sharing my screen. Okay, I believe that you can see that.
I don't see it yet.
Yeah, right now it should be fine.
Yes, yes.
Can you see all in one, because the Christmas are coming? So all in one, parametric design in connection, all documentation. So I just emphasize you to or encourage you to visit this web page if you are like a fan and enthusiast for parametric design. I do believe that this is the future of the structured design, to do it everything like a parametrically. Grasshopper, Rhino, and API. So here are some tutorials that you can go through from the basic to advanced. Also some articles, some GitHub, how you can like visit our GitHub, where it's just the community of the people that can help each other, and also some blog posts that are connected to parametric design. Of course, here is just if you go to the support and the learning, there is just a part dedicating to tutorials. That's if you go to the Open API, and you will just select the steel. We have also for RCS if you are just a concrete guy. As you can see, everything about the parametric design that's connected also with the Grasshopper API, and also the parameters inside the Idea Statica. What I really like is the API using the Python. So if you are a fan of Python or like scripting, so that's very juicy to use it, this option. Okay, I'm just passing the word to you, Dominic.
Thank you, Luki. I have 3 more questions. Please confirm that you can see my screen.
Yeah, I can see your screen.
Perfect, thank you. So one of you have asked, so if you want to modify design of one of the connections within the group, how you can do that if you just want to change the welds. What you need to do is remove this connection from the group, and then treat it separately, open the single connection app and modify the welds, so it won't be in the group itself anymore, because the philosophy of the group is, the logic of the group is that you propagate that whole design to all of the other connections. So that's one question. Another question was, how do you find out more about eccentricities? So, and wait, how do I find that? Just switch to the right version. So the StatiCa 25.1 release highlights and bulk work with whole structure simplified. And if you click on that article, it will take you there, and you can find out more over here. So that's that. And one last question is, somebody's asking if we know how much time can be saved with using this workflow compared to Excel spreadsheets. Well, I don't have anything that I would share. However, I want to say that we have done some tests, and what we found out is that it's up to 75%, even for like a very simple structure. So those are the results. With that, I would like to thank you, everybody, for tuning in. Have a wonderful day, and make sure to check out our website and get your quote if you are not using StatiCa already. Thank you very much. Have a lovely day.
Bye-bye. Have a lovely day.